In this how-to video, we're going to walk you through conversion factors. Conversion factors take units that you don't necessarily want and convert them into units that you want. So it's a very useful way to do this in your physics classes and your chemistry classes. So this is the first 2 pages of the guided notes. And as you can see, there are areas where we should fill in missing information, as well as figuring out and doing some math problems, and even dragging certain things so we can cancel out units. So this will make it very, very simple for you to have a reference to go back to when you have to do conversion factors in the future, no matter what class you're talking about, physics or chemistry. Here are the next 2 pages with example 2 and example 3. So we can notice that example 2, this is all just single conversion factors. So we're going to use one conversion factor for example 1 and example 2. This actually should say example 2. I got to fix that. Anyway, example 3 has multiple conversions. So that means there's going to be a couple different conversion factors that we use for that. And our 4th example, as you can tell, is also going to be multiple conversions. So we're going to walk through all of these together, like I said, so it's going to take us a little bit of time, but that's why I'm recording this, so you can take your time, rewatch every slide if you need to understand this. So from this point forward, we can tell that the bolded words are the words that we're going to want to fill into the blanks. So let's begin. Conversion factors. So conversion factors are multipliers that allow us to convert a quantity expressed in one kind of unit into an equivalent value expressed in another. So to convert from one unit to another, we want to start every problem with a question mark. The question mark means how many. Example 1 wants us to convert 152 centimeters to meters. So converting 152 centimeters to meters, remember, we're going to start with that question mark statement. So question mark meters, we're looking for meters. So that's why we have the question mark in front of meters. And we're going to have an equal sign, and then we're going to have what we already know, and that's 152 centimeters. We know the relationship between meters and centimeters, right? What is the relationship? Well, they both have meters in them, right? So they're both equivalent in the fact that we're talking about a distance in meters. So the base unit here is the meter. Centi is a prefix that means something in words, right? A centimeter is 100 times less than 1 meter. So centi means 100 times smaller than 1 base unit. So in this case, that base unit is the meter. So putting it together, centimeter, that's how we usually say it. We don't really call it centimeter, but whatever, centimeter is 100 times smaller than 1 meter. And 1 centimeter is also 1/100th, with a TH, 1/100th the length of 1 meter. So it's saying the same thing. So we can use an equivalent statement. So this is a statement with an equal sign in the middle, meaning that the left side and the right side of the equation or the statement is equal to one another. So this is a fact. We know that 1 meter is equal to 100 centimeters. Now, I always put the 1 in front of whichever value is larger. So since 1 meter is larger than a centimeter, then I'm going to put the 1 in front of meter and have 100 in front of the centimeters. So since we have an equivalent statement, 1 meter is equal to 100 centimeters, that can be expressed as 2 conversion factors, or in other words, these can be turned into a fraction. All right, so this is, again, the fact is an equivalent statement, but we can turn that equivalent statement into two different fractions, depending on what we put on top in the numerator and what we put on the bottom in the denominator. So it can turn into both of these. And notice all we've done is on the left side we have 1 meter in the numerator and 100 centimeters in the denominator, or we can flip it around. 100 centimeters on the top in the numerator and 1 meter in the denominator or on the bottom. So which one do we use? Do we use the conversion factor on the left with the meter on top and the centimeters on the bottom, or do we use the one on the right with centimeters on the top and meters on the bottom? Now remember, conversion factors are getting rid of the units we don't want and keeping the units we do want. So let's put our original problem on there. Again, we are looking for meters. Our final answer needs to be in meters, and we have 152 centimeters. So just so we know, any number written like 152 centimeters is really the same as writing 152 centimeters over 1 or divided by 1. So anything over 1 is itself, right? If you divide anything by 1, it's going to stay the same. But we do this and we want to understand that right here. We want to understand this because we know that 152 centimeters is in the numerator. And that's going to come in handy here. So which one do we use? So if we just put it over 1, I don't always put the 1 under there, but I'll do that in these demonstrations to help you guys. So 152 centimeters is in the numerator, so that means we want to get rid of the centimeters. So which one are we going to use? Well, if we have the same unit in the numerator as we do in the denominator, we can cancel those units out. So we're looking for meters. We need to set the problem up to cancel out centimeters. So I'm going to put an empty division problem here. And so we're just going to put our units in first. Since we want to get centimeters, get rid of centimeters and keep meters, we're going to make sure that we have centimeters on the bottom. Okay, so if we have the same things on the top and the bottom, like I said, the numerator and denominator, we can cancel them out. So if I put these units first, if I have centimeters down here, meters up on the top, then we can fill it in by just looking up here. This is what we're talking about. 1 meter is on the top, so we're just going to fill those in. So that's all I did is take this left conversion factor and use that to multiply by the number that we had, 152 centimeters. So right here, we're setting this up so that we can get rid of centimeters and keep meters. So now all we have to do is cancel out the centimeters. So let's get rid of the centimeters. We're just going to cancel them out. We're going to put a line through them. And so we can see that the only thing now that that's visible to us, the only unit that wasn't canceled out is the meter. That's the only thing. And it's in the numerator. So the meter is what we were looking for. See, that's what we're looking for, and that's what we have. So we're all good there. The remaining unit is the unit that we're looking for, the meter. We're good. So to solve this, we are actually going to, there's no more centimeters because that was canceled out. So it's really the number 152 over 1. Remember, that's anything over 1 is really itself. So we want to do that so we understand what's in the numerator. And let me get a different color here. These two things right here, 152 times 1 meter, those are the numerators, right? And then I'll do a different color in green down here. We have 1 times 100 in the denominator. All right, so that's what we have. So we want to multiply all the numbers that are in the top, the numerators. So 150 times 1. 152 times 1, sorry, is 152. And then we're going to multiply the denominators, 1 times 100. Well, that's 100. So it's really just saying 152 divided by 100. So 152 meters divided by 100. That's really what we're saying. So we have 152 meters divided by 100. And that's, you don't even need a calculator for that. You can just move the decimal point to the left 2 spaces. So 100 has 2 zeros, right? This is our decimal point right here, even though it's not listed, that's where it is. So really dividing by 100, we're just going to move that decimal place 2 spots to the left, and that's going to leave us 1.52 meters. So 152 centimeters, we'll go over this again, is equal to 1.52 meters. So we have essentially solved this because we were looking for meters question mark meters. So 152 centimeters, we use our conversion factor, and then we were able to divide the numerators by the denominators, and we came out with our final answer for example 1 as 1.52 meters. Let's move to example 2. In this example, we have to convert 62 kilograms to grams. So the same things we talked about, same setup. We're going to do the same thing for this, although we got to go from 62 kilograms into grams. So let's do it. All right, kilograms, that's what kg stands for. Grams, that's what little g stands for. So we know the fact. If you look on your SI measurement sheet, or you Googled anything like this, if you had to, you can find the relationship being 1 kilogram is equal to 1,000 grams. Again, that number 1 goes to the bigger number. So we know that a kilogram, kilo, means 1,000 times greater than a gram. So we put the 1 in front of the bigger of the 2, and the kilogram is the bigger of the 2. So we have 1 kilogram is equal to 1,000 grams. This can be, again, expressed as 2 different conversion factors, which are the same as just saying 2 different fractions. So we could either have the 1 kilogram on the top or the 1 kilogram on the bottom. So literally just take that equivalent statement up here and we turn it into 2 different, that's a terrible arrow, but 2 different fractions. All right, that's all we've done. We should be getting the hang of this a little bit. The more and more you practice, the better you'll get. So convert 62 kilograms to grams. Our first statement here, first thing we're going to talk about is making that question mark statement. So question marks grams, that's what we're looking for, right? And so we're going to say that's equal to what we start with, which is 62 kilograms. So we set up our problem. We're going to need one of those 2 conversion factors. So which one do we want? That's the question. Again, 62 kilograms is really 62 kilograms over 1, right? And so to get rid of kilograms and get into grams, we're going to want to use the conversion factors that will allow us to do that. So we're going to want kilograms to be on the bottom so we can get rid of it. So if kilograms is on the bottom, that leaves grams on the top. So we already know the numbers there. We've just taken our equivalent statement and flipped them around so that we can put our numbers in there. So 1 kilogram is equal to 1,000 grams. We wrote it like this because we want to get rid of those kilograms. So if we do, we'll scratch out the kilograms. That leaves us grams all by itself. And then we're ready to do it. So we're going to multiply the numerators. 62 times 1,000 grams, that's 62,000 grams, divided by 1 times 1, which is 1. So really our final answer is going to be 62,000 grams. And we didn't even have to use a calculator at all on this. That's the really good thing about the metric system, is that sometimes you don't even need a calculator, you just move decimals. In this case, we didn't even have to move a decimal. So it was easy. Let's go to example number 3. Now here's that weird symbol. This is saying convert 1,700 microliters. That's what that is. That's a Greek symbol mu. And then liters is always a capital L. So this is saying microliters. And we're going to convert that to deciliters or deciliters. That's really the way we say it, but deci. So we got to look at our SI measurement sheet to see what those mean. So microliters and deciliters. So we got to go from 1,700 microliters into deciliters. So let's begin. Our first order of business is always going to be put that question mark statement there. So we're looking for deciliters, and we're saying question mark deciliters equals 1,700 microliters. So that's just all the information that we've already known, and we have to just kind of start from there. After that, we know we have to get it into, well, first of all, we got to ask ourselves, they both have liters, right? So they're, a way that I do this is a multiple step conversion. So I would suggest if you have a multiple step until you get really good at this, I would convert it to what you understand. So a microliter and a deciliter both have liters in common. So that might be an easier thing to get microliters into liters and then liters into deciliters until you get really good at this. So let's continue. If we want to get rid of microliters, we're going to want to make a conversion factor so that microliters is on the bottom. Since one is on the numerator and one's on the bottom, we can cancel those out. And we know the relationship between microliters and liters. That's why we want to use this first conversion factors. So in 1 liter, since it's bigger, I'm going to put the 1 there. 1 liter is equal to 1,000,000 microliters, because micro means 1,000,000 times smaller than a base unit. So microliters are 1,000,000 times smaller than a liter. So that's how we're going to set this first part up, but we're not going to be done yet. We got to get rid of the microliters. There we go. But now we're in liters, and we actually have to get into deciliters. So we're going to need another conversion factor. So what we're going to do there, the liters is in the top in the numerator. So we want to get rid of that. So we're going to want that in the bottom. So there we go, liters and deciliters. So we know the relationship there. A deciliter is smaller than a liter by 10. So there's going to take 1 liter is 10 deciliters. So if we get rid of the liters, cancel those out, there we go. We are left with just deciliters, and that's exactly what we were looking to do. Our next step is to multiply all of the numerators and multiply all of the denominators, and then divide the numerators by the denominators. So let's do that. If we did that, so 1,700 times 1 is 1,700, times 10 is 17,000, because we're just moving that decimal place to the right 1 space. And if we divide that by 1,000,000, we're really just moving that decimal place to the left. And you find that this is your answer, 0.017 deciliters. And now we're on to the final example. So we want to convert 0.0056 millimeters, small number, to kilometers. Again, we want to understand the relationship between them so we can find equivalent statements that are equal. So I can already tell right now we're going to want multiple conversion factors. We're going to, since they both have meters in common, we're going to go from millimeters to meters and then meters to kilometers. So here we go, millimeters to kilometers. So we're going to start with a question mark statement. Question mark kilometers equals what we know, which is 0.0056 millimeters. So let's get our first conversion factor ready. Since we have millimeters in the numerator, we want to get rid of it and get to meters first. So let's put those together. All right, millimeters will cancel. That will leave us with meters. We know the relationship between meters and millimeters. We know that a meter is bigger, and 1,000 millimeters will make 1 meter. So we have 1 over 1,000 there. So let's get rid of millimeters. We're in meters. We don't want meters. We want a kilometer, right? So let's go put another conversion factor. We want meters in the denominator, so it will cancel the one that is left in the numerator. So once we do that, we know kilo means 1,000 times greater. So 1 kilometer is 1,000 meters. Let's put our conversion factor there. We can get rid of our meters. And that leaves us kilometers in the numerator, which is exactly what we were looking for. Now again, you multiply all of the top, the numerators, which is the same, because 0.0056 times 1, it's just the same thing. So it's going to be 0.0056. And then the denominators is really, if we put the 1 in here, obviously there's still a 1 here. So 1 times 1,000 is 1,000. And then if you use 1,000 times 1,000 is 1,000,000. So we're basically saying 0.0056 divided by 1,000,000. And when you do that, you don't need a calculator. You just move that decimal place to the left 6 times and you'll get the answer. So the answer is going to have a lot of zeros. So I converted that already to scientific notation. So if you don't know what I just did there, we can actually do it for you over here. So 0.0056. And I can do a different color here, so let's try that. We're going to move this 6 spaces to the left. 1, 2, 3, 4, 5, 6. So I'm going to put my decimal there. I'm running out of room here, sorry. Here's a 0 in front. 1, 2, 3, 4, 5. So I put all the eggs in the basket, I like to say. So this is a lot of zeros. This is actually a 0 in front. Sorry, it's hard to see in our decimal points right there. I keep on screwing up here. But then if we did this in scientific notation, we know our rules. We want a number between 1 and 10, greater than 1, less than 10. And so if I see that, let's do it and let's do it in purple, just so we know. We're going to actually, and I'm doing lines all over the place here, so sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where I'm going to move it. So that's where this 9 comes from. And it represents a very small number. So 5.6 times 10 to the negative 9th is our answer in scientific notation. So that should conclude our guided notes on conversion factors.